So, look at that. Lovely day, isn't it, eh? And you can tell from the trees behind me we're not having a breath of wind, and it's been like that for the last 3 or 4 days, which is really awesome considering the time of year we are, and really a bit of a pain when you just consider I've just built a massive wind turbine. So for the last 3 or 4 days, I've not been able to get it out there and see how it performs, which is a bit disappointing in a way, I suppose. But it has given me an opportunity to look at other things, and that's why we've been doing slightly different videos, because we're just having still days. Now, it's supposed to pick up in the wind at the end of the week, Thursday, Friday time, they're saying. So a day like this, we get a chance to look at this some more, rather than trying to get it all done. Because there's no point. We've got about 3 or 4 days before we're going to be able to take it outside anyway, which is a bit of a pain. But it has been a lot of fun and very instructive and very interesting. And of course, I have been reading the comments and listening to what people have been saying, and I'm thinking about some of the issues that people are having and some of the worries that they've got. Now, one thing that people seem to think is that I'm changing my mind, and I'm not. The same principles are applying all the way along. What I want is a decent device that will produce usable power that can be made by anybody at a cheap price. That's what I'm after. Now, the principle that I'm exploring is that the speed of the magnetic field as it passes the coil is important, not the torque. And that's what this device is. This device actually turns about 10 RPM or so in this blower. Now, it looks faster to you because the blades flash by the camera. But if you concentrate on one of the chair legs and put it against a marker like one of the fins and count it, you'll find it's about 6 seconds. Now, I'm counting in my head, so it might not be 6 seconds. I can live with that. It's a rough estimate of how fast it's going, and it's not going very fast. Okay, that's all we really need to take away from there. However, despite the RPM being low, this circle's large, so the speed is quite high at the rim of the circle as it passes the coils, and that's what this is all about. Now, I've made this from stuff I've found, apart from the blades, which I bought, and to a degree I've been lucky in finding the board, but I did look up the price of this board. This board is about $100 for a 2.4 by 1.2 metre sheet. So even if you wanted to make this whole thing brand new, you're probably talking around about $300 to $400 to make the entire thing, if you bought everything. That's a long way from a couple of $1,000 that a windmill will cost you. Now, any board that is weather resistant and stiff is going to do. I'm just lucky to have used this nice spacey board, but if I hadn't found that, I'd have used something else like plastic board or probably even timber actually, but loads of things that could be used to make that. I'm just lucky to find this. If you want to buy this, it's not that expensive actually. So the structure is very approachable. Now, I used all of those square edges because I wanted it square. So when I cut these fins, I cut them off the end. I cut them off the end because the top and the bottom are square. The reason they need to be square is going to lay on this board, and this board is square, so it makes getting them square an absolute piece of cake. You just sit them flush against each other. That's the beauty of these man-made boards. They're squarer than we can get them because they're made by machine to be square, so they're beautifully square. Now, to my mind, that squareness is a real issue. It's what's important about this. The distance the magnet is from the coil is critical. The closer you can get the magnet to the coil, the more power you can get out, because the magnetic field falls down by the strength of the square of the distance. So if I used ceramic magnets like I'm using here and replaced them with neodymium magnets, but it was a centimetre away, I'd lose all that benefit. I wouldn't have a better machine by using neodymium magnets because the construction would be poor and I'd lose all that field effect. So to my mind, there's no point in spending an enormous amount on neodymium magnets if you aren't actually getting this thing square. Getting this thing square, getting that distance close, is really what matters. Buying neodymium magnets or ceramic magnets actually makes very little difference in light of the squareness. You'll get a much better result if the thing is square and those magnets are close to those coils. That's what you should strive for. Don't think about buying expensive neodymium magnets. They rust in the rain anyway, and if it's not properly made, you won't get any benefit from them, but you will have spent a fortune on them. Concentrate your efforts and your money and your time on getting it square. It's a simple thing. I mean, it really is. But that will have the biggest impact. Changing the magnets, doubling them up, all that sort of stuff will have negative impact or near no impact if the thing isn't square. Making it square from a square material is going to have the biggest impact. It's astonishing how simple these things are. Now, when we've made a decent machine that is square, and that is true, it will rotate very, very easily. As we've seen this many times, it rotates easily. Now, this only turns at 10 RPM. In a high wind, it's probably going to do about 100 to 200 RPM maximum. We aren't talking about something that's going to be spinning at 3, 4, 1000 RPM. So although it wouldn't hurt to balance it, balancing it would be nice, and I probably will balance it, it's not essential. It's just not turning that fast. So we don't really need to worry about those kind of things too much either, because it just doesn't need to turn that quickly. Now the speed at the rim is fast, so these blades do need to be tied down reasonably well. If they break and fly off, then they're not going to decapitate you. If you do worry about them cutting your head off, put a bit of mesh over here to capture them. That'll take care of that. Don't worry too much about those things. If you do, stick some mesh on it, you'll be fine. Now that brings us down to the coil and magnet arrangement, which people think is the critical element of any generator. So I'm trying to point out to you the critical element of a generator isn't the coil and magnet arrangement. It's how well you've built the cage. Build that, that's the critical. The coil and the magnets, actually, from my investigations, they don't matter that much, to be honest. And I know that's almost a heresy to say such a thing, but it really doesn't matter that much. Now I've chosen to put a continuous ring of magnets around the bottom there. And I've had many people tell me that a continuous ring of magnets is a good idea. And I've had many people tell me that a continuous ring of magnets is a bad idea. It seems that when people have an idea about something that they think is right and that they can defend, they will defend it, even if it's contradictory and opposite to somebody else who's defending an equal position in the opposite direction with the same belief in it. The only belief you really have to have is to try and see. And that's exactly what I've done. Now, it didn't make sense to me that you needed to leave this gap between magnets. The reason it didn't make sense to me is these things, stepper motors. These are all over the place. You find these in printers, you find them in fans. If you pull them to pieces, what you'll get is a coil wound stator and the rotor. If you look inside the rotor, you'll see a continuous magnet. These things obviously are motors, but if you rewire that into a delta configuration with a 3-phase rectification on it, pop that back on, it makes a pretty decent generator. Actually, it makes a good generator. So it didn't make sense to me that the magnets had to have a gap, because in reality, in other forms, they don't have a gap. So it made no sense to me, so I chose no gap, and I'm not seeing any difference whatsoever. This idea of the magnet swapping north-south and causing a fight in the coil just didn't make any sense to me at all, and I don't think it happens. AC current obviously does change direction. That's the nature of AC. It doesn't create a particular issue at any stage in time, so I didn't bother with it, and I don't think you need to. If you have a favourite magnet arrangement, like you want them all north, all south, gaps between in various stages, explore them, but I really don't think it matters, particularly in light of the construction. Make it so the tolerance is near, and then by all means concentrate on whatever your favourite arrangement is. Mine is just a continuous ring, and I'm quite happy with that. It seems to work just fine, good enough for me. If I want to play around with it, I probably will do at some stage or other. Now, obviously, we spent quite a bit of time yesterday with coils, because coils, cord or non-cord, also seem to be critical in the same way that people think magnets are critical. I don't think that that's critical either. The magnet arrangement and the coil distribution and arrangement really just doesn't seem to matter that much in terms of the generation. Because I assume that when we start linking them up, we'll start getting different kinds of issues, for sure. But in terms of actual generation, then I've tried a whole load of things. The only thing I can discover that makes any difference at all is the number of turns and the thickness of wire. And it's basically, the thinner the wire, the greater number of turns you can get. And that means the higher the voltage and the lower the amperage. And then the reverse is true. the thicker the wire, the lower the number of turns, and so the lower the voltage and the greater the amperage. That's about all I can say about it really, and it seems to be all that really matters. And I've tried a lot of arrangements. So I've taken this microwave oven transformer with its secondary coil. We get about 30-40 volts out of that, and a few hundred milliamps. This one, where I've put ordinary household wire on it, and I've got 20 turns on that, get about a volt out of that, about 4 or 5 amps. So it really just doesn't seem to matter that much, to be honest. We talked about uncord and cord in the previous video. So of course that led me to look at a whole host of different arrangements, including a single pipe. A single pipe jammed on a bit of iron. I tried that, and I got a few milliamps and a few millivolts out of it, which I thought was kind of awesome. I also tried this, which is the coil out of the centre of a relay. It's a relay coil. That works fine, actually. I took this, which was a normal motor. So I took a normal motor like that with the coil on either side and sawed it in half and used 2 halves. And again, I got quite a good response out of it actually. I forget exactly what that was, but it was quite good. I quite like that idea of high voltage. So, if we take some of these things, and these are shaded pole motors, you find them in fans. This is obviously from a microwave, and it has a little armature there and then a single coil there. You saw off the armature, so you get this, which is half the armature and the coil. That does really well actually. We'll spin that up in a minute because that will light the lighting panel, no problem at all. So that was really nice. Now I'm not looking at all of these coil arrangements just to change my mind about things. What's in my mind is what's available to you. Now we could go making these coils, could go buying these coils, but I'm thinking what can we find lying around to repurpose in a relatively large number so that we can just use them straight away and we'll get a reasonable amount of use out of them in terms of generation. That's the main motivation. That's why we looked at these things, which are the ballasts out of fluorescent lights, because they're just all over the place. You find a ton of these things. They're really quite cheap and easy to get hold of. I saw somebody advertising 200 lights for £60 taken from a school, and they were the big lights, so there were 4 ballasts in there, so you could get 800 ballasts for about £60. I mean, that's just astonishing, isn't it? So the reason we're looking at different coils is not because I'm interested particularly in the coil function. What I'm interested in is what can we get for nothing or next to nothing that still gives us a usable result when we bang it into our machine. And the reason I'm interested in that is economics. Nothing to do with performance. They all perform pretty much the same, actually. There's not that much difference between them. So if you've got your head into perfect arrangements with star-shaped coils, various winding types, you're probably going down the wrong path, particularly if this is the first time you've made something like this. If this is the first time you've made something like this, what you need to be concentrating on are not esoteric patterns of coils and magnets, but the quality of your build. Your quality of build is going to have a much more of an impact than any fancy coil arrangements or worrying about the magnets and how the magnets might be arranged. That's actually relatively trivial aside the quality of the build of the main rotor and cage. Anyway, I'm going to take this, link it up, and I'm going to light up one of these. Remember, these are 31 volts at 700 milliamps. It'll light at a lower milliamps, but there is a minimum forward voltage it needs. So let's see if we can light one of them up. Our shaded pole motor coil, here's our lighting panel. Let's stick that close and see what happens. And there we go, we can light that panel up. Okay, so this is not about me changing my mind about what it is that I'm going to use. It's about me exploring possibilities of what might be available to you. So if I'm using microwave oven transformers and you can't find them, then that doesn't mean your project is dead. You have lots and lots of options. These things are a good one, which is the electronic ballasts from fluorescent lights. Again, you may not have those available to you, in which case these things are a good option, which are the coils outside of from the inside of shaded pole motors. Works really well. If that's not available to you, these things are an option, which is just a normal motor, which I've cut in half and then I let the magnets pass through there. Gives me a good result as well. So lots of things are available, including sticking a bolt through a coil of wire. There's just such a lot of things that you could use, and that's me exploring those things rather than changing my mind about the things. It's to give an illustration that an awful lot of stuff can be used. Now there's one really interesting thing actually. I mean, it's all very interesting, but there was one super interesting thing that came out of today. Remember I tried that copper pipe? I also tried our ink. I got a bit of plastic and I painted a U-shape on the ink about the same size as the copper pipe, and I tried both of them and they're in fact comparable. That astounded me actually, and it is going to lead to further investigation about what can be done with a painted coil as opposed to a copper coil, because I got a pretty good result out of a painted coil. I also tried it by connecting the two wires together and sticking the two wires under the magnets to make sure that it was in fact the ink giving me the result and not the two wires. So that was quite fascinating actually. Anyway, I hope this has explained a few things really about why it is I've been looking at the different things I'm looking at. What is the important aspect of building something like this? And so the takeaway message I really want to pass is, get out of your head that magnet arrangements and coil arrangements are super important. They are, but not as important as the quality of build of your rotor and cage. This mechanism is far more important. Anyway, I hope the video is of interest and thank you very much for watching.